Okay. Um, Now the subject for today is the first test. One thing I realized yesterday when I took a look at the test was because I'm going through all the different homework problems that you've had from the beginning and picking out certain ones to include in the test. And for some reason, um, one of I'd selected one of the wrong problems, so I had to replace that, and therefore the corresponding practice test was also updated. So this happened yesterday, um, and I believe don't I can't be 1,000% certain, but I believe it was problem number 4 was the one that I had changed. So if any of you have had taken a look at the um, practice test before today, because like I said, I changed it sometime yesterday, but one problem has been swapped out. So. But you have the rest of this week before the real test comes out to try your hand at it and be ready for it. Okay. So my plan for today is I'm going to talk. So rather than go through specific problems like I normally do with the homework, I'm going to talk about the types of problems that you can expect on the test and use that as an opportunity to go over some main ideas from the chapter. So things that you should keep in mind, and kind of things you should be able to do for the test. All right, so get my document going here. And there are only 6 problems, so this probably won't take very long, but should have some worthwhile information. Sorry, I was trying to get the screen share going. Okay. So what kind of problems can you expect to see on the test? So the first type of problem, and this is coming from indicate the section that these problems come from, so that you can go back and review the homework for that if you want. So given a set of vectors, A1 up to AN, or it may be given to you as a set of vectors, or maybe you're given a matrix, and then we're talking about the columns of a matrix. Is a given vector B in their span? So is B part of a span of these vectors? Or it could be asked this way: is B in the span of the columns of a matrix A, which would be these vectors here? Okay. So what you would do is, really what this boils down to is a system of equations AX equals B consistent? And if it does turn out to be consistent, so it is in the span, what would be a solution X? In other words, what would be a linear combination of these vectors A1 to AN, or the columns of A, that so what linear combination of them would actually give you the vector B? All right. Now, So how would you proceed with a problem like that? So what you would do is you would row reduce A, and just to cover different types of ways in which this question can be asked. So if you're not given a matrix, but rather a collection of vectors, then you make them into a matrix. Okay. All right. Sorry, I just had a notification to check out in Teams. Okay. And actually, it's not just A. It's the augmented matrix, which sometimes I've written it this way. If A and then B added onto it, that's what makes it an augmented matrix. Okay. So whatever vectors you're given in whatever form, those are the first columns, and then, whoops, and then you have B as the last column. Okay. All right. So once you have that matrix, you go to echelon form is enough. You don't need to go all the way to reduce echelon form. And I've picked out problems that do not require going to reduced echelon form. Okay. So then you go ahead and check if a system is consistent. So it is consistent if there is a pivot position in every row. That would certainly guarantee that no matter what B is, that there is a solution, that the system is consistent. Or if that's not true, if okay, if you have rows that are entirely 0, including this last column corresponding to B. So if you had like all zeros in a row from over here, but you have something non-zero next to it, that would be an inconsistent system. Okay. All right, so that's how you can tell. Okay, and then actually something I want to take a peek at here. All right, for the test. Okay, now once you determine, suppose you find that the system is consistent, so B is in the span of these columns. If a question asks you for a specific linear combination, so in other words, coefficients, which would be the elements of X, so that X equals B, then you have to actually have to come up with a solution. Then use what I referred to before as back substitution, where you are obtaining the values of the unknowns by starting from the last equation, which is the simplest, solving it, and then substituting values in the equations above it to get formulas for all the unknowns. Okay. I want to make sure that I'm not giving you incomplete information here. Okay. Sorry, my labs is being very slow. Okay. Okay. So that's one thing you need to be expected to be able to do is you to expect to be able to do is if you find a system is consistent, so B is in the span, find a specific linear combination, and so by this process of substituting the last equation on up, will give you that linear combination. All right, so those are the kind of manipulations you can expect to have to do for a question like this. Now the next kind of problem, I have to find a parametric solution of this system linear equation where you have 0 on the right side. So in other words, you're describing all possible solutions. Okay. So a process in that case, again, you row reduce, but there's no need for an augmented matrix because the right-hand side is 0. And then once you have it row reduced, you want to identify any free variables, and then any basic, so non-free variables. So you want to classify each of your unknowns corresponding to each column of A as either free or not. And then the next thing you would do is solve for all the basic variables in terms of the free variables. Okay. So for instance, if like x3 and x4, if you have 4 variables in total, x3 and x4 happen to be free, then you're going to express x1 and x2. So the formulas for x1 and x2 will involve x3 and x4. Okay. So the free variables become your parameters in this parametric solution. So once you've done that, then the answer that you would actually have to enter, my labs would be vectors consisting of coefficients of your free variables. So like, so for example, if you have 2 free variables, x3 and x4, then so all of your unknowns can be expressed in terms of those 2. Then you can write it as a sum of 2 vectors, one involving x3, one involving x4, and then you can factor out free variables So what's left in those vectors are the coefficients of those free variables. Okay. Oh, and this is from section 1.5. Let me make a note of that here. Okay. So that's something that you've had to do in that homework. Okay. Questions so far about either of these two types of problems? Okay. In response to a question in the chat, I mean, today I'm just talking about the general process. I'm not sure if I fully understand your question, but so I'm just highlighting it here, but the main concepts that you have to know to work the various problems that come up in this test. And what I would suggest is afterwards, going back to the relevant homeworks. Now, not all homeworks are featured on this test, but most of them are. To like 6 out of 8. That you can revisit these type of problems, and if you didn't get them in the homework, if it's something that you definitely want to take a closer look at to make sure you can do it on the test. So no, I'm not doing my usual thing today where I'm picking out specific problems, but these are on the practice test. So you, based on the information you get from this review, but you can go there and try them out. Okay. Now the third type of problem. So this is from 1.7. Okay. So you're given a set of vectors, or you may be given a matrix and you're talking about its columns. Are these vectors linearly independent? So you can formulate this as an equivalent question, because pretty much everything we do here all semester long tends to boil down to solving some kind of system of linear equations. Ax equals b, or maybe ax equals 0. So if the vectors that you're given in whatever form are the columns of a matrix A, does this system ax equals 0 have only the trivial solution of the x equals 0? So if you find that is the case, and easiest way to tell this is if there's a pivot position in every column after you perform whatever row operations are needed to get to echelon form, then the given set of vectors are independent. So that's how you can answer that question: are they linearly dependent or not? Now, if they are not linearly dependent, you can see this in practice test too. There are 6 questions altogether. I'll be going through the 6 different types here. All right, so if they're not linearly independent, then the system Ax equals 0 has a non-zero solution. X, and the problem may ask you to find such an X. So what you could do is to find such a linear combination, because you have when there's a non-zero solution, therefore you have at least one free variable. So you can literally set that to a variable to whatever you want and get a non-zero solution. So the way you get a non-zero solution is you set a free variable equal to 1. But that's something that would work to get that kind of solution. The other thing I want to point out is if Ax equals 0, then okay, actually I'll write it this way. So if X is a solution, dang it. Any multiple of X is also a solution. So that's one thing that's important to keep in mind when you have Ax equals 0 specifically, because if Ax equals 0, then I multiply X by something. Well, then I'm just going to end up multiplying this vector by that same something. I'll scale both sides, and I'll still have 0 over here. That is not true for Ax equals b, for whatever b might be, but when but you can always scale solutions of Ax equals 0 and still have solutions. The reason I make this point is suppose you have a situation where you find that the vectors are not linearly independent, and the question asks for what is a linear combination of these vectors that gives you 0. So in other words, what's a solution of Ax equals 0? And so then so you got to go ahead and find such a solution by setting a free variable equal to something non-zero. But what my labs could do, and they did do this in the homework, is they specify one of the unknowns for you, and then you have to solve for the other one. So that's something to keep in mind. Okay. All right. And the thing is, all these problems tend to involve some kind of row reduction, and then you figure out something based on what you get from that row reduction. Okay. Oh, let me check here. Oh. Actually, neither one. Set one of the unknowns for you. And in that case, you would use that to solve for other unknowns in terms of that. Okay. Next, we have from next section 1.8. So he's next to get into linear transformations. Okay. So given some kind of linear transformation T, and a vector X, and I want to emphasize it can either be a specific vector, like I give you actual numbers for X, or a generic vector like X1, X2. But you would handle either case the same way. Find the image of X under a transformation T. So really what you're doing is you're just substituting X into the linear transformation. Okay. All right. So what you can do is you can find a matrix of T So if you apply linear transformation to each of the standard basis vectors, remember these are the vectors that are have all components 0, except one of them that's equal to 1. Okay. Depending on how MyLab phrases a problem, they may actually give you these. So then you just simply put them together as columns of the matrix. This is also referred to as the standard matrix. All right. Now, once you have that, then the T of X that you're looking for is the same as A times X. So you're computing a matrix vector product. And just to review how you actually carry that out, you're multiplying each column of A. Actually, I'll write it this way. The jth column of A by the jth element of X. So each column of this matrix is multiplied by the corresponding element of X. And then you add them all up. So you take a linear combination of the columns of A, the coefficients in a linear combination come from the vector X. So once you take a linear combination, then you have your image of X under the transformation T. And so this is one of the few problems on this test where you're not having to row reduce anything or do any kind of like substitution. Okay. Next, all right, from section 1.9. Okay. I will admit that there's not much to this next one. Okay. So I need to get back to the right window here. Wait, what am I missing here? Hold on. Yes, I have filled in. Okay. Okay. This is what I was explaining. To get the matrix vector product, multiply every column of X by these elements of X. Once you multiply all of them by their corresponding X's, you add up all of those. And that's it. That's my explanation of how to do number 4. Does that make sense? Please let me know. Hold on, I have a lot of editing to do here. I really want to take just one column in each of these cases. Okay, so that's all I mean by matrix vector product. First element of X times first column plus second element of X times second column plus third element of X times third column, however many columns you might have. Okay. Next. So again, given a linear transformation T, find a standard matrix. And I had typed that out earlier, so let me go ahead and grab that. Okay, so to get the standard matrix, each column of a standard matrix comes from applying the linear transformation to each column of the identity matrix. And it's important that you have off the top of your head these columns of identity. Now here, this is a three-dimensional example, but it's however many dimensions you have. Okay. Okay, and so on for whatever dimension of your space. Whoops. Okay. So like in some problems, MyLabs actually gives you these. If not, they would describe linear transformation in some other way. Like it might give a formula for linear transformation, and then you can apply it to each one of these vectors and get the columns of a standard matrix that way. Okay. That's actually all that's involved with that problem. The last one actually circled back around to an earlier section, section 1.2. To this application problem, I thought if it's going to be a word problem in a test, I'd prefer to save it for last. Okay, now and it'd be a problem involving solving some kind of system of equations, ax equals b. Okay, now so for this problem, excuse me. So for this one, using a system of equations that's fully written out as a system of equations would normally be written out. As an example, something like this. Okay. Something's off here. Oh, okay. So suppose like you might have like a system of free equations, free unknowns, something of this form. So these coefficients, the aij, those would be the elements of your matrix. The y's would be your right-hand side, and then the unknowns would be C0, C1, C2. So matrix, the coefficient matrix of a system would come from all of these values, these aij. So first column, second column, third column. So just like other problems, we're solving x equals b. You can then work with the augmented matrix for this system. So first column, second column, third column, and then these y's would make up a fourth column in this case. And that's going to be no different than any other system x equals b. So you perform row operations, and you substitute from a bottom equation up to find the values of these unknowns, in this case C0, C1, C2. And then what you'd have to enter in MyLabs requires you to understand, like, well, the solution that you're getting from this system, what does it actually mean? So you'd have to just decipher that from the problem statement. Okay. Though we've been doing this from the beginning, okay. A quick review of the central row operations, because you never know which ones you might need to use. Sometimes it's a good idea to interchange rows. You want to move zeros to the bottom, or another reason to interchange rows is to make sure that the pivot positions go in the right order. And the reason for that is, in echelon form, each pivot position must be to the right within the matrix. So when you're looking at the pivot positions must always be ordered in such a way that they would go from upper left to lower right. If they deviate from that, that means that you should interchange rows so that they do appear in such a manner. All right. So those are, though, so row interchanges may not be necessary, but here that's a couple of reasons to go ahead and use that. Number one is certainly less essential, but could still come in handy. So scaling a row by some value. that can be helpful to keep the numbers nice. Like, for example, you've seen some problems I've worked through where, like, suppose all of the elements in a row are divisible by something. If you have a common factor, then you can go ahead and divide by that common factor. It can be convenient to make pivot positions equal to 1. So that can save some algebra later. So this is like for convenience so this can also help cut down on mistakes, especially if it gets you out of having to deal with any fractions. All right, and then the most important row operation of all is okay, so all right, so you're trying to eliminate elements. So whatever row you're scaling to subtract from a row, it's always a row that's below it. To carry out this elimination, this is to get to echelon form. I'm not talking about reduced echelon. Okay. Okay, so the multiple is given by aij over ajj. So aij, that's the element you're trying to eliminate. So you're trying to get all certain entries in a column equal to 0. So let's suppose this is the one that you want to get rid of. All right. And a JJ that's up above it, same column, it's basically what you're using to eliminate it. Which is easier to do if the element's equal to 1 to get the right multiple. And that's why sometimes these other row operations might come in handy to make this make this entry equal to 1, and so chances are it makes the numbers work out more nicely. Okay. Actually, since sometimes we may have columns without pivot positions, okay, I need to make this a little more general than I did. Okay. All right, so I'm going to choose column K here. So AIK is the element being eliminated, and this is a JK. All right, so it's not necessarily an element that's on a diagonal. Okay. All right. So that's always the ratio that you use when you are subtracting a multiple of row J from row I. So that's very important. It's subtracting, not adding. All right. And of course, you'll be using these in several of these problems as you have been doing in the homework. All right. So that's my quick tour of the problems from a practice test and therefore a real test. To get an idea of the kind of tasks that you need to perform. So the last time I checked, there wasn't much activity for the practice test. There's still a good amount of time. Today's only the 16th, and then the real test is put out there for you to use, for you to take on Monday, the on the 21st. So then, so for that first day, for Monday, I will send everyone a Canvas message that has the password that I've set for the test, just to safeguard against accidental entry and starting a clock when you don't intend to. You have 75 minutes to complete the test. So basically the equivalent of one full class period. So if you go to the practice test, try it out. If you have any difficulties, and certainly let me know. Does anyone have any questions about the test? Okay. Yes, it will be graded, but that is not the end of the story. I will manually review every test, because in case there's a situation where some partial credit should be given. Now, one thing I want to point out is for a practice test, I'd forgotten to set point values. So on the practice test, it just has every problem being worth 1 point. So on the real test, I'm going to assign each question a point value. They'll be roughly equal. So an average of 16 and 2/3 points each, because there are 6 problems. But it's something that's going to add up to 100 points. So that'll give me some leeway to attempt to give partial credit based on whatever work of yours that I see. And just as a general rule, it probably won't be necessary. I stated that earlier. 75 minutes is the length of a test. No, there's nothing to scan in. As I was saying, it's probably not necessary for this class, but I've had to do this in other classes where I give these kind of tests. That once I see how the class as a whole is performed, sometimes I do apply a curve. But that's something I would make a general announcement about later, like after I've graded everybody's. So I guess you could say that when you take the test, whatever score my labs give you, your real score will be greater than or equal to it. I didn't say that you actually would be showing your work. I'm just saying that what I would infer from what you did provide to my labs as your answer. Sorry, I wasn't clear about that. Okay. Are there any other questions about the test? I don't recall how my labs is, but like it never sites like my labs. Even when the question clearly breaks down into multiple parts, as certainly most of these problems will, um, that it may not necessarily break your score down by parts. In other words, like giving you credit for parts you did right, etc. So that's one reason why I manually review every test, so that uh, after I see what he did, like especially if there's certain parts right, certain parts wrong, that I can make sure that you get appropriate credit. And my labs might decide that not to give partial credit because it may not want to know how I break it down, but that's something I would take care of. Yes, September 25th at 11:59 p.m. By the way, I'd come across an issue a few days ago that the time zone for this class was wrong. It was set to Eastern time, so I've since corrected it to Central time to make sure that when I say that assignment's due at 11:59, that it really is due at 11:59, not 10:59. So Friday, September 25th, 11:59 is when it has to be in. So then over that weekend is when I'll take a look at them. So at least by Monday, in case there's been any increase in your score for whatever reason, you'll know about it by then. And these notes I've typed out here, I'll be putting those in Canvas as usual. All right. Are there any further questions? I should mention that during class next week, so the 21st and the 23rd, there will be I will be starting to cover material from the next chapter, but there will not be any homework due while the test is going on. So the next time there'll be assignment due will be like the 28th or something like that. So I'll still be covering stuff, but you won't need to do anything with it just yet. I originally planned to make the test due September 21st, but I wanted to, especially at the start of a semester, I wanted to make sure I want to give people more time to do those first homeworks. So I kind of pushed everything back. Okay. All right. I will end the recording now. So then anyone who doesn't have questions, you're free to go at this time. And if not, then I'll be here for you to ask.